Welcome to Electronics Engineering Technology Fundamentals. Your instructor, Dr. Oscar Rodriguez, once again. And we have discussed part 1, part 2, and we've been covering actually part 3 already. This coming discussion that we have is lecture number 8, which is the closing of part number 3. And of course, after that, we got part number 4 and then part number 5 to conclude with the course. So let's go into today's lecture to cover the topic of principles and properties of AC signals. Another important component of this electronics engineering technology fundamental class, if you want to have a basic understanding about electronics engineering technology. Okay. So the objective is to be able to identify the properties of AC signals, or they are also called wave signs. In other cases, they are called sinusoidal waves. All right. So the topics for today are going to be the properties of AC signals, and we'll talk briefly about harmonic and AC signals. We talk about the polarity of a sine wave. We will discuss period of a sine wave. We will discuss frequency of a sine wave. And we briefly talk about the relationship between frequency and period. We actually have roughly covered a little bit in our previous lecture, but this lecture is going to be a little more in-depth regarding breaking out the AC signals. All right. So first of all, I don't think that I have to introduce this symbol before. So this symbol represents an AC signal. Anything that generates a sine wave or sinusoidal wave will be represented by this symbol. As a matter of fact, that represents a generator, an AC generator, okay? So I wanted to introduce that concept before I talk about harmonics and AC signals. And the basic definition of harmonics is that there are signals that result from combining two or more AC signals. In this graphic, we have two harmonics. Actually, there's three, with what we call the fundamental frequency or fundamental harmonic, sometimes called. And notice that the green sine wave is the fundamentals or the basic. Then we got a blue sine, which we call that the first harmonic. And then we got a red sine, which we call the second harmonic. And notice that each one of them doubles in frequency. The first harmonic is double the frequency of the fundamental, and the second harmonic it's actually triple the frequency of the fundamentals and double the frequency of the first harmonic, if that makes sense. In essence, a harmonics is really a sign that is the combination of two or more signals, and there could be more than two, okay, for that matter. All right, then let's talk about polarity of sine waves. Again, we're just discussing sinusoidal waves, but we could have triangular waves or square waves, and some of these concepts also apply to that, although there might be a slightly different information that applies to that. But sine waves or sinusoidal waves will have polarity, and that polarity is an important aspect of analyzing sine waves. Sine waves have also amplitude, as we discussed previously, and the amplitude is how big or how powerful that signal is, whether that's current or voltage. We also have on the sinusoidal wave what we call positive polarity and negative polarity, which is labeled plus BP and minus BP, stand for voltage peak. It's BP, and that will be positive voltage peak, the upper part of the sine wave. And I want just to concentrate on the one cycle. All right, so if we take the origin of the cycle here, this will be the end of our first cycle. Now, I will explain a little more why the period is labeled that way. But once again, this is the peak amplitude or the positive amplitude. And from this point to this point, we describe that as voltage peak to peak or peak to peak amplitude. We also have RMS or root mean square amplitude, which, as we discussed before, is the equivalent of a DC voltage source that do the same work that an AC source will do. So once again, the important concept here is to recognize that there's a positive bullish peak and there's negative bullish peak, and there's what we call bullish peak to peak. And the bullish peak to peak is going to be created by the rotations and the frequency and the intensity of that bullish being sent out to the output of the generator. And again, we can be referring to either current peak negative, current peak positive, current peak negative, or current peak to peak, as we describe this. But the main thing here is we're dealing with bullish, and so those are the labels that I use for bullish. All right. Additionally, we talk about period or time, which is the same of a sine wave, described as the time that an AC signal requires for the completion of a single or complete cycle. The symbol for time is T, or period. It can be measured actually in three forms. So in other words, if I start measuring the signal from this point to this point, a full cycle, that will be my period. All right, and period can be measured in three forms: zero crossing to zero crossing, which is the case right here. From this point to this point, that will be zero crossing to zero crossing. Positive to positive. So if I start here and I end up somewhere in here, that will also be equivalent. And you could also measure the period from negative to negative, and that is if I start at this point here and I end at this point, that will be a full cycle. The time in any case should be the same, right, for a sine wave. Okay. In addition to that, we can talk about frequency of a sine wave, and this frequency is defined as the number of times the sine wave is repeated within a given period of time, essentially 1 second. So let's just say that our whole axis here of time is 1 second. Let's just say from this point to this point is 1 second. Okay, so if we figure how many times the complete cycle is repeated in that second, we can determine the frequency. And in this case is from this point to this point, that will be 1 cycle. From this point to that point, that will be 2 cycles. And from this point to this point, that will be 3 cycles. So in this given length of time, assuming that's 1 second, we have 3 cycles. And that fits the definition of the number of times the frequency is repeated within a period of 1 second. So that would be 3 hertz, or 3 cycles. Okay. You can compare frequency and period, and notice that time and frequency are inversely related. In other words, as the frequency increases, the time required for a full cycle decreases, right? And so here again, we have, imagine that the period is the same on both signals. So the period from this point to this point is the same as the period from this point to this point. Now what's the difference? Here we only have 1 cycle versus here that we have 3 cycles. So frequency and time are inversely proportional. As the frequency increases, the time required for a full cycle, it decreases, and vice versa. If the frequency decreases, that means that the time required for that 1 cycle will increase. So keep that in mind as we move forward. Let's do some basic calculations. And here again, we have some signs that we're looking at. And so if the period or time for this sine wave is 2 seconds, which it is, right? From this point to this point is 1 full cycle. And so the time is 2 seconds. What is the frequency of the signal? And so by mathematics, it's essentially frequency is equals to the reciprocal of time, or 1 over t, and 1 over 2 seconds, which is the time for the 1 cycle. That gives us a frequency of 0.5 hertz. Or you could also say 500 millihertz. That's another way to say it. Okay? And here's another example. Now our time has changed for a 4th cycle here. The time is now 1 second. So if the period for the sine is 1 second, what is the frequency of the signal? Pretty easy, right? But you get the point. Frequency is equal to 1 over t. 1 over 1 second, that will be 1 hertz. 1 cycle per second. All right? And finally, if the frequency is 2 hertz, what is the period or the time? So then you reverse. Now you use the formula T is equal to 1 over F. So 1 over 2 hertz gives us 0.5 seconds or 500 milliseconds. So in this case, it takes 500 milliseconds for a full cycle to be completed from this point to this point, or from this point to this point. That's what frequency and period are, and they're inversely related. Let's review before we go out. We said that harmonic and AC signals are the result from combining two or more AC signals, right? And we call the fundamentals the first signal, and then the first, second, third, and so on harmonics. We talk about polarity on sine waves, and we also said that in the amplitude that we discussed previously, you also have what we call positive, negative polarity, also called positive peak and negative peak, or positive frequency, negative frequency. And that polarity can actually be measured from various points, from the zero crossing to the zero crossing of the next one, and it can also be measured from the positive to the positive and from the negative to the negative. But they do have polarity. Period of a sine wave or time is defined as the time needed for a single cycle to be completed. The symbol for time is t. All right, and frequency of a sine, frequency of an AC signal is the number of times the sine wave or the sinusoidal wave repeated within a given period of time, essentially 1 second. And then we finally talk about the fact that frequency and time are related, inversely related, and that is, as frequency increases, the time required for a full cycle decreases, and vice versa. All right, that is lecture number 8 on the properties of AC signals. All right, and once again, this was Principles and Properties of AC Signals. I'm your instructor, Dr. Oscar Rodriguez, and I'll be seeing you in our next part of the course. We are actually, with this lecture, finishing up the third component, big component of this class. I will see you next time. Have a great day. Don't forget to take the quiz. Do well. See ya. Bye-bye.